Hi, dear children. Today our teaching topic is operations on sets. Hi children, till date you have learned how to perform four fundamental operations on numbers and variables. Now let us discuss basic operations on sets. At first, let us see. Suppose A is the set of students in your class who were absent on Tuesday. Let A is equals to Amisha, Kalyani, Pujita, Kiran, and the set of the students who were absent on Wednesday. Then B is equals to Pooja, Bhavani, Aishwarya, Raviteja, Kiran. Now we want to find the set of the students who are absent on either Monday or Tuesday. A is equals to, we know Amisha, Kalyani, Pujita, Kiran. B is equals to Pooja, Bhavani, Aishwarya, Raviteja and Kiran. But now K is equals to Amisha, Kalyani, Pujita, Pooja, Bhavani, Aishwarya, Raviteja, Kiran. Now, symbolically, we represent A or B as A union B, and we read as A union B. A union B is equals to Amisha, Kalyani, Pujita, Pooja, Bhavani, Aishwarya, Raviteja, Kiran. If we observe A union B, we find all the elements of A or B, isn't it? K is equals to A or B is equals to A union B is equals to X such that X belongs to A or X belongs to B. How can we represent A union B in Venn diagrams? My dear children, observe on the screen carefully A and set B. We have taken two sets in the form of circles, and entire region A and B is A union B. Is said to be A union B. Observe another example with numbers. A 5, 6, 8, 9, 10, 12. B 3, 4, 9, 10, 11, 13. A union B is equals to 3, 5, 8, 9, 10, 11, 12, 13. Since 9 and 10 are repeated, so we have taken only once. Now in the same sets in Venn diagram. Observe carefully on the screen. The elements which belongs to both A and B are written in the middle. Now let us discuss about intersection of sets. Let us consider example of absent students again. Let us suppose A is the student in your class who are absent on Tuesday, the same student on the screen, and the set of the students who are absent on the Wednesday are also the same names given on the screen. And then now, that is this time we want to find the set L of students who were absent in both Monday and Tuesday. We use that L is equals to Kiran. Symbolically, we represent A and B as A intersection B, and we read as A intersection B. A intersection B is equals to Kiran. K is equals to A and B. It will be written as A intersection B. That is, X belongs to A and X does not belongs to B. Let us observe how they are represented in Venn diagram. See the entire region A and this is entire region B, where the two regions have intersected in the middle. That is A intersection B. Now let us observe another example of intersection of sets. Now, what are the common elements in the given two sets A and B? 6 and 7. Now let us observe how to represent the difference of sets. Consider A as the factor of 30. A is equals to 1, 2, 3, 5, 6, 10, 15, 30. And B is the set of odd numbers. That is, B is equals to 1, 3, 5, 7, etc. etc. Now from the above given sets, take all the elements that are factors of 30 and which are not odd numbers as set D. Then D is equals to 2, 6, 10, 30. By observing the elements of D, we can generalize that the set D contains only the elements of A but not set B. Symbolically, we represent D as A minus B. A minus B is equals to 2, 6, 10, 30. And then the same thing will be represented in the Venn diagram as shown on the screen. C 2, 6, 10, 30, which belongs to only A, the only A region. That is represented as A minus B, and X belongs to A and X does not belongs to B. Now, let us consider another example. Observe how we represent B minus A. A is equals to 3, 4, 5, 6, 7. B 6, 7, 8, 9, 10. Similarly, for B minus A, the elements which are only in B but not in A are taken. Now B minus A is equals to 8, 9, 10. And observe carefully on the screen how it is represented with Venn diagram. See, only B are 8, 9, 10. This is only region B. B minus A is equals to 8, 9, 10. Now, let us observe some applications of union and intersection of sets. A is equals to 5, 6, 7, 8, 9, 10, 11, 12, and B is equals to 5, 6, 7. Now, A union B. 5, 6, 7, 8, 9, 10, 11, 12. That is nothing but A. If A consisting of some elements, A 5, 6, 7, and B is more elements, then A union B is equals to what? The elements which are all in A and B are B only. If B is subset of A, then A union B is A, and if A is subset of B, then A union B is B. Remember very well. Now, observe another result. A is equals to 10, 11, 12, and B is equals to 15, 16, 17. The set of A and B do not have any common elements. We call them as disjoint sets, and their intersection is an empty set. A intersection B is empty set, pi. And we represent with the Venn diagram as separately drawn circles from each other. They do not intersect. Another example. If A and B are two sets such that A is subset of B, then what is A union B? Is nothing but B. A union B is equals to B. Now, equality of sets. Two sets are equal if they have precisely the same members irrespectively of their order. Example, are A and B equal, where A is the set of first four natural numbers, B is 4, 2, 1, 3. Let us check. They both contain 1, they both contain 2 and 3 and 4. And we have checked every element of A is in B. So, yes, they are equal. Finite set. Finite and infinite sets are two of the different types of sets. The word finite itself describes that it is countable, and the word infinite says it is not finite or uncountable. Example of finite sets. P is equal to 0, 3, 6, 9, etc., 99. It is countable up to 99. A set of all English alphabet, that is only 26 will be there, that is countable. Q. A is such that A is an integer 1, less than A, less than 10, that is also countable. A set of months in an year is also a countable set. Clearly, January to December we can count, that is enough. M is equals to 12. Now, can we say an empty set is finite set? An empty set is a set which has no elements in it. It can be represented as with two only braces and shows that it has no element. P is equals to only braces or pi. As the finite set has countable number of elements and the empty set has 0 elements, so it is definite number of elements. So with cardinality of 0, an empty set is a finite set. What is infinite set? If a set is not finite, it is called infinite set because the number of elements in that set is not countable, and also we cannot represent it in the roster form. Thus, infinite sets are also known as uncountable sets. Example, a set of whole numbers W is equals to 0, 1, 2, 3, 4, etc. A set of all points in a line, a set of all in triangles, a set of leaves on a tree, the set of hair on the head. Such type of sets cannot be counted. Comparison of finite and infinite set. Let us observe factors. Number of elements in the finite set. Elements are countable, and in infinite set the number of elements are uncountable. Now, as for the continuity is concerned, it has a start and end element, but it do not have endless from start or end. Both sides could have endless. And cardinality. N of A is equals to N, we can count them, but it is infinite, we can't count. Union. Union is also finite. Union of two finite sets is finite, and union of two infinite sets is also infinite. Roster form. It can be easily represented in roster, but the infinite set cannot be represented in the roster form. Recap. Observe carefully on the screen, my dear children. A, B. This is region, entire region represents A union B. This small middle region A intersection B. That region only A minus B A, or this is only B minus A B. Observe some problems on the screen and try to do on yourself. If you did not get, just you approach your class teacher.